Look up, please. Next question. Next question on growth and decay problems. Next question here. Question here says, a certain country had a population estimated to be 49,600 in the year 1972 during the census conducted that year. 10 years later, the population grew to 73,600. Assuming the rate of increase in population is proportional to the number present, A says, obtain an equation for predicting the population of this country at a future time T. Okay, let's get that done, please. That's the A part. The B part says, anyways, B part says, predict the population of this country in 2018. The C part says, in what year will the population be 162,000? Let's solve this one, please. A part, please. A part, please. Please watch this very well. The question there says a certain country had a population estimated to be what there? 49,600. Okay. How do we solve this? First things first, we know that they said something. They said assuming the rate of increase in population is proportional to what there? The number present. The rate of increase in population, the x over the t, is proportional to the number present. So we have this. Now, since this is an increase in population, becomes what there? Positive. Positive. So I'm having this as dx over dt. It's equal to what there? Kx. We have this. We've solved this before now. What we said at the end, we'll have that word there. X is equal to a exponential what there? Kt. We did this before now. So if you missed that class, please check our previous video where we solved this, right? This has already been explained in our previous class. Now, let's use the conditions to get the value of A and K. The first thing there, hold on. They said a certain country had a population estimated to be, so X is equal to, what time there? 49,600. In what year there? 1972. The question now is this: does it mean that T is equal to 1972? The answer is what? No. We are taking 1972 as what there? The initial. That's at T equal to 0. This is the year 1972. This is my initial. So any year after now, you just do what there? Add it up. If T equal to 0 in 1972, in 1973, T will be equal to what there? 1 year. In 1974, T will be equal to what there? 2 years. In essence, in this question here, T is measured in what there? Years. That's it. All right, let's impute this here. X, 49,600, that's X. It's equal to A, unknown, A exponential K, T unknown, times T, 0. From here we have 49,600. It's equal to A. This will give you exponential, what there? 0. K times 0 is 0. And that's equal to, exponential 0 is 1. 1 times A is A. I've gotten A to be 49,600. That means this equation is simply X is equal to A is 49,600 exponential KT. K and then T. Let's get the value of K. How do you get the value of K? Use the second condition. Second condition says what there? 10 years later. So at T equal to 10. Of course, T is in years. So that makes sense. T is equal to 10. 10 years later. What's the value of X? 73,600. So I have this. Okay? Let's impute this condition into this equation and get the value for what there? K. X 73,600 is equal to 49,600 exponential k. K is unknown into t. T is 10. Right? T is 10. I want to divide here by 49,600. I want to divide here by 49,600. This cancels this. This value, what do you have here? Give me like 4 decimal places. 1.4839. Well approximated. This is equal to exponential 10 what's there? K. Now, to get the value of k, simple. Take ln of both sides. So ln of 1.4839 is equal to ln of exponential 10k. You have this. All right. From here, ln will cancel exponential. You're having 10k. So ln of 1.4839 is equal to 10k. So you have this. All right, to get the value of k, divide here by 10, divide here by 10. This cancels this. Please give me the value, please. K is equal to, hold on, let me see here, let me see here. K is equal to, what do you have there? 0.039 5 or 95? 95. This? So if I already had 9 here, what do you have told, what would you have told me next? All right, so we have 0.0395 as the value of k. Let's substitute. So therefore, that was the a part. The a part should obtain an equation. So therefore, the a part, the obtained equation now is that x is equal to a. The value for a is what again? 49,600. A exponential kt. K is 0.0395 times what there? T. So I have this. So basically, this is looking like this is like 95 of t. No, for it says a function 95t. This way. For it says a function of t. Let's have this please. All right, so I've gotten the A part. What's the B part there? Predict the population of this country in what there? 2018. So B part in 2018. Please hold on, please. What was my initial date? 19 what? So 1972. You now said 2018. Please, from 1972 to 2018, how many years? Just simply punch 2018 minus 1972. How many do you have there? 40, 46 years. So please, this is what you do, okay? You get the exact date. So say it's 46 years. Just subtract them. So we have to find the population at t equal to 46. That's simply x equal to the equation there, 49,600 exponential 0.0395 times t. T is 46. Please punch all of this, please. Give me a fine answer. Just save me the stress. Sorry? 305207.18 approximately. That's 1 8 approximately. That's the size. So basically, this is how you solve the question. So that's the required size. Okay. Next in there, C part says, in what year will X be what there? 162,000. Of course, 0.00 there. So if X is 162,000, we have to find what there? T. What's that equation again? Okay, this is here. When X is this, so you have 162,000 is equal to 49,600 exponential 0.0395 times T. Let's find T here. Please, this is times T, not of T. To get this, we have to first of all divide here by 49,600. Divide here by 49,600. This cancels this. Please give me the value of this. 3.2661. This is equal to exponential 0.0395t. Okay. Next up, to get the value of t, I'll take ln of both sides. So ln of 3.2661 is equal to ln exponential 0.0395t. From here, ln cancels exponential, it goes off. So I have ln of 3.2661. It's equal to 0.0395t. Let's get t. To get t, divide both sides by this. So I have ln 3.2661, this all over 0.0395, it's equal to t, right? That's what you do. Divide both sides by this. What's the value, please? 29.96 years. Approximate this, what do you have there? 30 years. So to take 30 years for it to have a population of 162,000. So basically, this is how we solve this question, right? We'll do one more question, we'll go on break, all right? Go on break.
Get more by joining our Differential Equations channel membership or visit www.joniemanual.com/courses and get the Differential Equations Made Easy course. Both links in video description. Get more by joining our Differential Equations channel membership or visit www.joniemanual.com/courses and get the Differential Equations Made Easy course. Both links in video description.